Okay, 8.1 is inverse and joint variation. This is a short section. It won't take you very long. And we've kind of talked about it in the first unit. But if you have an inverse relationship, that means that x and y are going to be on opposite sides of the equal sign. And like as one goes up, so if y increases, then x decreases. Or if x increases, then y decreases. And we call A our constant of variation. So sometimes a question will ask you to solve for the constant of variation, or it'll ask you to solve for x or y. You're always solving for one missing piece. So an example is if you have one pizza that you're sharing with your friends, the more friends eating, the less pizza that you get. So think about kind of like a fraction. If you're having to divide it among 8 friends, you get 1/8. If you're having to divide amongst 10 friends, you get 1/10, so you get less pizza. Then if you have joint variation, you see a lot of these equations in chemistry, like the one that you see right here is from chemistry. But that's basically like they have a direct relationship, so that's another word for it besides joint is direct. But you can have different variables, and we call A the constant of variation. All right, so for number 1, we're given the equation xy equals 1/2. If I want to write this as an inverse relationship, that means I'm gonna get y by itself. So I just want to divide by x. So when I divide by x, I get y equals 1/2x, because the x goes to the denominator. And then it says determine y when x equals 8. So y equals 1/2 times 8. So y equals 1 over what? 16. Good. So for the second one, xy equals 9. So y equals what if I'm solving for y? 9/x, because I'm dividing by x on each side. And so determine y when x equals 8. So y equals 9/8. Then for number 2, if x and y vary inversely, find the constant of variation when x equals 3 and y equals -2. And then rewrite the equation. So I'm going to just write the equation by itself. Y equals A/x. Then I'm going to plug in 3 and -2, and I'm going to solve for my A, my constant of variation. So I would say -2 equals A/3. Then solve for A, so A equals -6. But then for part B, it says write the equation. So I'm going to rewrite it as an original with x and y, but I'm going to plug in -6 for A.
So is this like a different type of inverse?
Yeah, this is just a different way to ask the same question. So y equals -6/x. Okay, so it says if x and y vary inversely, find the constant of variation. So we're going to set it up like the last problem. And it gives me x and y. So y is 6, x is 4. So A is 24. And then the equation would be y equals 24/x. So for number 4, it says use the formula D equals RT, so distance equals rate times time, where D is the distance in miles, R is the rate, and T is the time in hours. A car travels a distance of 30 miles, rate times time. Do the rate and the time vary directly or inversely? So for instance, if I'm going faster, like I have a higher rate, does that mean that my time goes up or does it go down? It goes down. So would that be inverse or direct? Inverse, because if I were solving for rate, then it would be 30 over time. Or if I were solving for time, it would be 30 over my rate. So they would be inverse relationship, or they would vary inversely, because as one goes up, the faster I go, the less time it takes me to get somewhere. Or the slower I go, the more time it takes me to get somewhere. But that's none of you. So if z varies jointly with the product of x and y, then my equation is going to be z equals x times y. So x times y equals z. And I want to find A, write the equation, and determine z when x equals 1 and when y equals 7. So I need to add the constant of variation, which is A. Okay, so I'm going to solve for A in part A. So I'm going to plug in x, y, and z. So z is 2 equals A times 3 times 8. So 2 equals 24A. So A equals 112. So then if I were to rewrite the formula just by itself, I would say z equals 112 x, y. Then for part B, I'm going to do the same thing. So if I'm going to solve for A, we have, well, that's not a y. It should be z equals a x, y. So 3/4 equals A times -5 times 2. So 3/4 equals -10A. So A equals -3 over 40. That should be a -3. So then my final answer, if I'm going to rewrite the equation, would be z equals -3 over 40 xy. Okay, for number 6, it says the volume of a gas V at a constant temperature varies inversely with its pressure. The pressure acting on 15, what is that, meters cubed of air is raised from 1 atmosphere to 2 atmospheres, while the temperature is kept constant. So when it says the temperature is kept constant, that means that temperature is my constant of variation. Like that is my A. So find the volume of the air after the pressure is applied. So I need to solve for my constant of variation first, and then when the atmosphere is 1, because I know that when the atmosphere is 1, my volume is 15. Then when I find out whatever my constant of variation is, then I can apply that to 2 atmospheres. So the formula I would use would be volume equals temperature over pressure. No, it'll just be a word problem that you'll have to be able to apply it. So it gives me the volume is 15. Then my temperature, which I don't know what that is. So I'm just going to say T over, and then how many atmospheres? Just 1. So T over 1. So that's pretty easy because 15 times 1 is T. So my temperature equals 15, probably degrees Celsius, I would assume. I can't assume, so it could be Fahrenheit. Who knows? Doesn't tell me. So now I want to solve for volume whenever the pressure is 2 atmospheres. So V equals 15 over pressure is 2. 15 over 2 as a decimal is what? 7.5, and then it would be meters cubed. For number 7, it says the weight of a body varies inversely. So weight varies inversely as the square of its distance. The square means that it would be squared. So d squared from the center of the earth. On the surface of the earth, 4,000 miles from the center, a certain body weighs 125 pounds. So how much would it weigh 300 miles above the earth? So the formula that I would use for this would be weight equals whatever my constant of variation is over the square of the distance. So I would put d squared on my denominator because it says the square of the distance. The 2 things that I can solve for, or that I can plug in, would be my weight, and then it would also be my distance. So my weight is 125 equals A over 4,000 squared. Okay, so you should get, in your calculator, you should get A equals 2 billion. So you have 9 zeros. All right, now I want to figure out, okay, how much do you weigh if you're 300 miles above the earth? So if I have weight equals 2 billion, I'm going to put all of my zeros, over, what would my distance be if I'm 300 miles above the earth? 300 plus the 4,000 that I already am, because it's 4,000 from the center of the earth. But if I'm 300 above that, it would be 4,300 squared. Okay, so you should get 108 point what? 167, and that would be pounds. All right, number 8, last one. So we have power. This is a formula that you probably see in chemistry. So power varies jointly as the resistance and the square of the current I, so I squared. So my formula would be P equals R times I squared. For a 600 watt microwave oven that draws a current of 5 amps, the resistance is 24. So if you plugged all of that into the formula, you would end up getting, it would end up checking out. But it's saying, what is the resistance of a 200 watt refrigerator that draws a current of 1.7 amps? Okay, so you should plug in 200 for power, then you have resistance, and then 1.7 squared. So 200 over 1.7 squared gives me what? 69.2, and then that would be, that is beautiful.